A single weekly injection is changing the way scientists think about obesity, diabetes, heart disease, addiction, and possibly aging itself. Over 1 in 5 American adults have now used a GLP-1 medication, making it the fastest adopted drug class in pharmaceutical history. You have heard the names: Ozempic, Wegovy, Mounjaro, Zepbound. But almost nobody understands what these drugs actually do inside the human body. Today, we go inside the human body, in full 3D, to show you exactly how these drugs work at the molecular, cellular, and whole body level. By the end of this video, you will understand why these drugs cause weight loss, how they protect the heart, what they do to the brain, and why scientists are calling them the most important drugs of the 21st century. And you will understand both the extraordinary benefits and the real questions science is still working to answer. Before we can understand the drug, we need to understand the natural hormone it is designed to mimic. GLP-1 stands for glucagon-like peptide 1, and it is produced naturally by specialized cells in your gut every time you eat. GLP-1 is what scientists call an incretin hormone, a gut signal that tells the rest of your body that food has arrived and help is needed. The first target is the pancreas, where GLP-1 binds to receptors on insulin-producing beta cells and triggers a precisely calibrated insulin release. Critically, this insulin release is glucose-dependent, meaning GLP-1 only triggers insulin when blood sugar is actually elevated. This is why natural GLP-1 does not cause dangerous low blood sugar. GLP-1 also suppresses glucagon, the hormone that tells your liver to release stored glucose into the bloodstream. Now, one of the most powerful effects of GLP-1 happens not in the pancreas, but in your stomach. GLP-1 significantly slows gastric emptying, meaning food stays in your stomach much longer, keeping you feeling full for hours after eating. And GLP-1 reaches the brain directly, crossing into the hypothalamus and brainstem, where it powerfully reduces hunger and food cravings. Natural GLP-1 has one major limitation: it is destroyed by enzymes in the bloodstream within just 2 minutes of being released. Semaglutide, the active ingredient in Ozempic and Wegovy, is a molecularly engineered version of GLP-1 that has been modified to resist degradation and last for a full week. The fatty acid chain attached to semaglutide allows it to bind to albumin, the most abundant protein in blood, which acts as a protective carrier, keeping the drug safe from enzymes. This engineering extends semaglutide's half-life from 2 minutes to approximately 7 days, allowing a single weekly injection to maintain therapeutic levels continuously. When injected subcutaneously under the skin of the abdomen, thigh or arm, semaglutide forms a depot that slowly absorbs into the bloodstream. Once in the bloodstream, semaglutide binds to GLP-1 receptors throughout the body with extraordinary affinity far stronger than natural GLP-1. The pancreatic effect, glucose-dependent insulin secretion, and glucagon suppression operates exactly as with natural GLP-1, but amplified and sustained for 7 days. The gastric emptying effect is equally sustained. Patients on semaglutide consistently report feeling full much faster and for much longer after meals. But the most powerful effect, and the one researchers find most fascinating, is what semaglutide does in the brain. Semaglutide crosses into the brain and activates GLP-1 receptors in the hypothalamus, directly reducing the biological drive to eat. But it also activates receptors in the brain's reward center, the nucleus accumbens, reducing the pleasure and craving associated with food. The weight loss from GLP-1 medications is real and significant, but scientists quickly realized that something even more important was happening. In 2023, the landmark SELECT trial showed that semaglutide reduced the risk of major cardiovascular events, heart attack and stroke, by 20% in people without diabetes. This cardiovascular protection comes through multiple mechanisms all working simultaneously inside the body. First, GLP-1 receptors are present directly on heart muscle cells and coronary artery endothelium, and their activation improves cardiac function independently of weight loss. Second, semaglutide powerfully reduces systemic inflammation throughout the body, and inflammation is the primary driver of atherosclerosis. Third, significant weight loss reduces the mechanical load on the heart, lowers blood pressure, and improves lipid profiles, creating a compounding cardiovascular benefit. The kidney protection effects are equally remarkable. GLP-1 medications have been shown to significantly slow the progression of diabetic kidney disease. GLP-1 receptors in the kidney tubules directly reduce sodium reabsorption, lowering blood pressure, and reducing the mechanical stress on glomerular capillaries. GLP-1 medications also dramatically reverse non-alcoholic fatty liver disease, with some patients showing near-complete resolution of hepatic steatosis. Perhaps the most surprising discoveries about GLP-1 medications involve not the body, but the brain. Patients taking GLP-1 medications began reporting something unexpected. They stopped craving alcohol, and cigarettes, and gambling, and other addictive behaviors. Clinical trials are now confirming what patients were reporting. GLP-1 medications significantly reduce alcohol consumption, with some studies showing 50% reductions. The mechanism appears to involve GLP-1 receptors in the ventral tegmental area, the brain's reward generation center, where the drug reduces the dopamine surge that drives addictive behavior. GLP-1 researchers are also investigating whether these drugs could protect against Alzheimer's disease, with early clinical trials showing promising results. In preclinical models, GLP-1 receptor agonists reduce amyloid accumulation, reduce neuroinflammation, and improve synaptic function, 3 of the core pathological features of Alzheimer's disease. Some scientists are beginning to describe GLP-1 medications as potential longevity drugs because they simultaneously address multiple pathways of aging. They reduce chronic inflammation, the key driver of biological aging. They improve metabolic function. They protect cardiovascular and renal systems, and they may protect the brain. A new oral form of semaglutide pill received approval in 2025, making GLP-1 therapy accessible without injections for the first time. With all of these extraordinary benefits, it is important to also understand the real side effects and the genuine questions that science has not yet fully answered. The most common side effects are gastrointestinal nausea, vomiting, and diarrhea, affecting up to 44% of patients, particularly in the early weeks of treatment. These side effects are typically dose-dependent and improve significantly as the body adapts, which is why dose escalation protocols start low and increase gradually. A more serious concern, rare cases of pancreatitis have been reported. The risk appears small but is something physicians carefully monitor. Perhaps the most discussed concern is muscle loss. Studies show that a significant portion of weight lost on GLP-1 medications can be lean mass rather than purely fat. This is why exercise, particularly resistance training, is strongly recommended alongside GLP-1 therapy to preserve muscle mass during weight loss. The question of what happens when you stop taking GLP-1 medications is also important. Most people regain significant weight after discontinuation. This is because obesity itself alters the brain's weight set point. GLP-1 medications manage these alterations, but do not permanently reprogram them. The next generation of GLP-1 medications is already in development, dual and triple receptor agonists that simultaneously target GLP-1, GIP, and glucagon receptors. GLP-1 medications represent a genuine paradigm shift in medicine, not just for obesity and diabetes, but potentially for how we treat addiction, neurodegeneration, and aging itself. We are at the beginning of understanding what this drug class can do, and the next decade of research will likely reveal benefits we cannot yet imagine. Whatever your personal situation, the science of how these molecules work inside the human body is extraordinary, a reminder of the remarkable complexity of our biology.